Okay, so 6-1 is referring to matrices, and matrices are used universally over to make things just a little bit simpler in terms of your uh, like linear expressions and that sort of thing. So today we're gonna go ahead and show you how to change a matrix or linear systems and put them into a matrix, which is called an argumentative matrix. And then also, it's a way you can solve those equations so much easier. So remember those through that system of three equations. So anyway, when we had the like even the finding A, B, and C when you have the quadratic equation given 3 points. This is what's happening behind the scenes on your calculator, because your calculator also will calculate that by doing kind of a natural regression. But I know part of our objectives was to also know how to do it the long way. But this way, I hope you guys will love finding systems of equations with the matrix. Now, again, we've had already systems of equations where it just has X and Y. Those are linear equations too. But a lot of times it takes almost more time maybe to put them into a matrix than maybe solving it itself by either, So again, obviously when we get into the system of three equations, three variables with three equations, you're going to want to it's going to be a lot easier to use your matrices to solve, and it makes it just go a lot faster. So let's jump in. So a matrix, yeah, uh-oh. All right, let me try and get everything done since I'm so sorry. Had that first step done, but I just didn't have that part done. So the first thing we want to do is we want to know how to put a system into a matrix form. So a matrix again is just the shortened way to write the system of equations. When we talk about an argumentative matrix, what they're going to do is we're going to write it with vertical bars. So a bar will go here. And then what you want to do is you want to represent each one of your variables in the rows in the columns. So again, every equation would be then a row. Then all of your column would be then an X, the Y, and the Z, depending on your variable, plus what the solution that it's equal to. Notice that it's also set equal to a standard form of our equation. So everything is moved, all of my variables are moved over to the left-hand side, where then I have just one solution, so it's equal to a number. And so it needs to be written in this form. In other words, if I had a minus 5z over here on this other side, I want to move it over to one side. So my argumented matrix for this one will just be 3. Then my y value is going to be then a -2. And then I'm going to have 5 and then 31. So that will be my first row. Then the next equation will be my second row, which is going to be then a 1, 3, -3, and -12. And then the last equation will be then -2, -5, 3, and 11. And then so you have completed writing it in an argumentative matrix. Now we haven't solved anything yet. We're just going to put it in matrix forms. And this is what when your calculator starts to do when we input that in as a matrix, we're assigning it as a matrix. And then what we're going to do is we're going to perform different operations. Okay, so just like we've done before, you can add and you can multiply a matrix time like a row times a constant, and then you can add it. For instance, on this one, this is what we'll end up doing is taking then it says take -5 times R1 and then add it to R2. And that's representing the row 1, which would be over here, and then row 2 would be the second one. So if I take -5 times R1, I'm just going to multiply it here times this row. So -5 R1 will change to -5, -40. Now -5 times a -4 would be then a +20, and then a +20 for the last one. But then I'm going to add it to R2, and so I'm going to go ahead and write just R2, not changing it at all. So I'll have 5 5, 7, and 4. And then usually I'm going to go ahead and say, I'm going to add in that arrow, and then it replaces then R2. And so let me show you why. So if I were to add this together, I'm going to end up with a -5 times 5, which is going to be 0. This would be a -35. Then I'd have 27 and then 24. Our goal will be when we solve these equations is going to be to make the first one to be 1, but the second one, the first element in row 2 to be a 0. Okay, so then my new matrix then will look like 1, 8, -4, -4. But then I'm replacing R2 with this one, which is 0, -3, 27, and 24. And then I haven't done anything with row 3, so I'm going to just go -9, 7, 3, and 2. Now, what did this remind you of right here? Addition, exactly. All they're doing is they're doing addition in this, and then they're replacing it with a row, just like what we've done before. It's just that they didn't put all of the extras. And I assimilate this a lot to our synthetic division. So remember when we did the long division, you had to put all of the X's in there, and then you had to represent every part. And then on synthetic division, all we did was use the coefficients in front and manipulate it. And that's a lot what we're doing here with the matrices. Okay, so then we're going to go ahead and use matrices to solve different systems. So when we do that, goodness, I've got like a frog in my throat. The solution, the process in all of this is going, the stars are represent different numbers. Our goal is to get the very first row 1, R1 to equal 1. And then the next goal will be to have row 2 and row 3, the first element to also be 0. And then we're going to work on getting it so it's on the row 2, it's the next one is going to be 1. And then again, then we'll end up being 0 on the bottom. And then the last one will be then the third spot on row 3 is going to be 1. And what that does is then that if once it's set in this form, this is considered row echelon. Now, what I'm going to suggest doing, we're going to go ahead and take it one step further because this is the system, this is the process we wanting, and we can do that just like we did with taking R -5 R1 plus R2 and then replacing with R2. And then you're going to just keep doing that multiple times. I'm going to show you how to do it just with the computer though, or your matrix calculator. So the very first thing you do when you have a system of 3 equations, I'm going to ask you to use your calculator to put it into what we call reduced row echelon form. So the first thing I have to do is put it in the argumentative matrix. So I'm going to start off in the first one will be then writing the coefficients of each of my terms in those rows. So I'm going to start off with 1, -2, -1, and 2. My second row, you want to do that one? Perfect. And my last one, I'll go -1, 1, -2, and -4. Now, I went ahead and I did put a link to just the Desmos matrix calculator, and that's the one I'm going to use, but you can use, there are several other out there that you could also use. So again, I kind of like the Desmos ones. It gives me a system. I went ahead and put one in. Let me go ahead and clear it. Let me just do clear. Okay, I'm just going to type in a new one. I checked to see if my last equation was actually, but I want to use here we go. I'll clear everything. Okay, so I'm going to clear this and then I'm going to start with a new matrix C. So that's what you'll do first. And you start off with a 2 by 2 always. And it's a 2 by, so we need to make it, if you notice, it's not a 2 by 2, but in this case, it's going to be then a I'm going to move over my rows. So I'm going to end up with 3 rows, but I'm actually going to have 4 columns. So 3 rows and 4 columns gives me a 3 by 4 matrix. Then I'm going to put it into just type it in. So I'm going to have 1, I'm going to end up going -2, -1, and then 4 or 2. And then the next run would be then 2, -1, 1, and 4. And then I'm going to go -1, 1, -2, and then -4. So I've inputted my matrix into that. So now it's my argumentative matrix. And then I'm going to go ahead and just save that. I'm going to hit new matrix. But then I'm going to, oh, I didn't want to, sorry, I want to clear that. So I'm going to go ahead, after I put my matrix in, I'm going to go down to the button, which is the RREF. And that's what I put in parentheses. And then all you have to do is type in A. When you do that, you get this to change to, by using that Gestalt method, you have a new matrix of 1, 0, 0, 1, 0, 1, 0, -1, and 0, 0, 1, and then 1. And this is going to tell you then my solution. So since the 1 is representing my x value, that means x is equal to 1, y is going to equal a -1, and z is going to equal 1. Oh, sorry. So when you the solutions then are noticed, then it's after you get into reduced row echelon, it's also, we're looking at this diagonal where ones are diagonally across. We are going to talk about what happens when it's not, when there's no solution, because what happens is that it'll go diagonally across, but then this one might be 0 also. And so then it shows you that we're going to have to do something else. That means there's multiple solutions to my equations and not just one. So anytime you put it in reduced row echelon form, and diagonally it goes to 1, and then everything else, the 3 by 3 matrix over here is the other numbers are 0, then our solution is going to be that last column. Okay, so I'm going to do a couple more. I also have another one where, if you notice on this one, we don't have a y value, and you have to represent the y value with a 0. And so I have an 8, a 2, a 5, and a 1. I'm going to have a 2, a 0, a 3, and a 5. And I'm also going to go 4, 6, 7, and -3. Now, your calculator will also do that same thing. Rather than go to your matrix calculator on your computer, if you have a graphing calculator, you should have, let me quit. Okay. In your button, your second one, you look for the matrix button. So see in your calculator, do you have a matrix button? Is it that one? Could be. Does it pop up something that looks like this where you can input them? I can look in your calculator later to see if it does. So what I'm going to do is I'm just going to put this matrix in. I have a ability to put different matrix in this calculator. So I'm going to go ahead and go down to 2, and then I'm going to edit my second one, and I'm going to hit enter. So matrix right now for B, you have to tell it how large you want it. And in this case, I have again a 3 by 4. So I'm going to change that to a 3 by 4 matrix. And then I'm going to go ahead and input my numbers. So I'm going to go 8. I do have to usually hit enter on those rather than just tab over. And then I go 2, 5, 1, just like I've done before. 2, make sure you have the 0 represented if you don't have a variable. And then 4, 6, and 7. Now, I do want to point out I have a -3. If you use your operation button, if I put a -3 here and then put -3 and then enter, it will not work. Okay, so you need to go ahead and use it. Let me clear that cell. You need to go ahead and use your negative button down whoops, maybe get a little higher. So you have to use this button and not this button to make it negative. So then I'm going to put a -3. So now I have my matrix inputted in, and it's matrix B. So at this point, I'm going to quit, and then I'm going to go back into my matrix, but this time I'm going to do the math. And we're going to talk about determinants later. But in this case, I'm going to go ahead and scroll down until I find the RREF button. And so I'm going to click on that. Then I also need to tell it which matrix I'm going to take the redo row echelon in, and I'm going to go ahead and hit enter. And then so I selected B and hit enter. And notice then my reduced row echelon form from my calculator then will be then 1, 0, 0, -0.5, 0, 1, 0, -0.2.5, and then 0, 0, 1, and then 2. Now, you may be asking yourself, what is she going to want to see for her test? So what happens is, even though this is so simple to go ahead and use either your calculator or, again, you can use your Desmos calculator. Makes it super easy. But look at the problem that we did earlier. If I have one of these numbers wrong, if I put it in as 1, I still got a solution. Okay, but it's the wrong answer because I have this one field inputted incorrectly. So the input is so important, and it's so easy to make one slight mistake and then you'll have the wrong answer. So if you're trying to put solutions in and you're not getting the right answer, go back and make sure you've inputted everything in correctly. So what I want to see on your test is something that looks a little bit more like this. I want you to go ahead and just check. Okay, so I'm going to ask again, I'm going to tell on your homework, see if I can get it. Let me go ahead and put this up. If this is again my reduced row echelon, I'm saying that x is equal to -0.5, y is going to equal -2.5, and z is going to equal 2, which also leaves me to the way I could write it as a coordinate as -0.5, comma, -2.5, comma, 2. And that means if I substitute that back in, if I have x times a -0.5 plus 2 times a -2.5 plus 5 times 2 is going to equal 1. It better be a true statement. And so this is what I'm going to ask you to also show me just to make sure that you've inputted everything else correctly. So I'm going to go times, I'm going to go a -0.5 plus 2 times a -2.5. And then I'm going to go, I think yeah, plus 5 times 2. And I do get 1 equals 1. And so that's a check. And then I'm going to do that for each one of my equations. Well, my second one's a little bit easier. So 2 times a -0.5 plus 3 times 2 is going to equal then 5. Remember, this is going to be then a -1. So 2 times a -0.5 is a -1, plus 6 is going to equal 5. And so that one checks out as well. And then I would do that for my third one. Now, keep in mind, I don't know whether you're going to do that or not on your homework. But again, if you have problems, you need to make sure you didn't make a slight error up here. But then on your test for this unit, I am going to ask you to also check it just to make sure that you're right. Does that make sense? That is our homework assignment for today. And let me go ahead and stop recording.